Hello everyone, welcome to this question on classical mechanics. This question appeared in December 2018 consisting of 3 marks. Question says, consider the two-dimensional motion of a mass m which is attached to one end of the spring whose another end is fixed. That means we have something of this sort. One end of the spring, this is the spring that is given to us, and we have some mass which is attached to one end through one end to this spring, and this spring, it has K as the spring constant given to us, right? And the other end of this spring is fixed. Say this is fixed, this end is fixed. Now they are saying the kinetic energy T and the potential energy V of the system is given by these two expressions. So they have in question given us the kinetic energy and potential energy. So we do not have to go through which forces are acting on it and things like that. Here it should be dot. So and r dot, that is given to be dr by dt, and q theta dot, that is given to be d theta by dt, and t is the time variable. Then which of the following statement is correct? So they are asking whether r, this is an ignorable coordinate. If theta is an ignorable coordinate, r square theta dot remains constant throughout the motion, or r theta dot remains constant throughout the motion. So here, if you remember the definition for ignorable coordinate, what is that? Any coordinate qj that is an ignorable coordinate if the corresponding if the partial derivative of the corresponding Lagrangian with respect to that coordinate comes out to be 0. If this is the condition, then we call this coordinate to be the ignorable coordinate. So before answering these two options, let us first go for calculating the Lagrange. So the Lagrangian that is given by t minus v, t is given to be half m r dot square plus r theta dot square minus what is v? V is half k r square. So now this is our L. So what are the corresponding Lagrangian equations? So the Lagrange equations of motion, because in our case we have two generalized coordinate, one is r, another is theta, so we have two equations, right? So what would be these two conditions? They would be, first is this del L by del r minus d dt, because the independent variable over here is time, and dl by dr dot, that is equal to 0. Another equation that would be del L by del theta minus d dt of del L by del theta dot, that is equal to 0. This is dot, right? So let us solve this one by one. So what do we have? Solving this equation, we have our L as half m r dot square plus r square theta dot square minus half kr square. Therefore, del L by del r, that would be 0 plus half m 2r theta dot square and minus half k into 2r. We just take the partial derivative. We assume theta dot, theta and r dot to be constants. So this quantity, this comes out to be m r theta dot square minus kr. Another thing, we just calculate the partial derivative of L with respect to r dot. So it would be m r dot, right, only. So substituting these two values in the given equation, this one. So what do we have? We have m r theta dot square minus kr minus d dt of the second quantity m r dot, that is equal to 0. So we have m r theta dot square minus kr, and here m is constant, being the mass it would be constant. So you have to take the derivative of this r dot. So it would be r double dot. Dot here represents derivative with respect to time. So it would be m r double dot, that is equal to 0. So one is this equation. call it as equation number 1. Let us solve another equation in the theta coordinate. So firstly we'll have to calculate what is del L by del theta. So as this term does not contain theta, this term does not contain theta, and this also does not contain theta, so it simply is equal to 0. So now you get del L by del theta is equal to 0. So what can you say about theta? Is it a ignorable coordinate? Yes. We have theta as the ignorable coordinate. Why? Because del L by del theta is equal to 0. So accordingly, they are asking theta is not an ignorable coordinate. So this option is incorrect. And what about r? Did you get del L by del r is equal to 0? No. We got it to be something else. It is non-zero quantity. Therefore, this r, this is also not an ignorable coordinate. Theta is ignorable coordinate, but r is not. So these two options are incorrect. So remaining for the remaining options C and D, let us just solve the second equation, second Lagrange equation. So we have del L by del theta is equal to 0. Now let us calculate what is del L by del theta dot. So first term does not contain theta dot, it would be 0. Second term contains theta dot, so it would be m r square theta dot. And third term also does not contain it. So we have del L by del theta dot, that would be equal to m r square theta dot. So substituting these two values into this equation, so we'll have 0 minus d dt of this quantity m r square theta dot, that would be equal to 0. So or when you integrate this, you'll get m r square theta dot, that would be equal to constant. So you got this quantity as constant. As m is also constant, therefore you can also take this to the right hand side. So we'll have r square theta dot is equal to some other constant. So this option C, this is the correct option, because this term is constant and we cannot say anything about this term. So this option is incorrect, because we do not get any term where r theta dot, that is constant from here. So we conclude that our option C, that is the correct option. Well, that is it for this video. Thank you for watching.